Hello, myself is Dr. K. Manikanta from the Department of Electronics and Communication Engineering in the Marri Laxman Reddy Group of Institutions. And today our subject is in 21 PTSP and the subject code is 2530403. What is the course objectives and what are the course outcomes? Course syllabus, textbooks, and electronic resources available for studying this probability theory and stochastic process. And what are the different modules you have in the probability theory and stochastic process also here discussed. Module 1, probability and random variables, operations on random variables, and multiple random variables and operations on multiple random variables, random process and random process with respect to temporal characteristics, with respect to spectral characteristics. These are the 5 modules we have discussed in the overall PTSP subject. And for our introduction program, we will tell about what is the probability and how to calculate the probability, and what are the applications in the ECE, why you are studying the PTSP, and applications in engineering also will discuss. Coming to the course objectives and course outcomes, what is meant by course objectives and course outcome? As the part of OBE, at the outcome based education, we have to know what is the use of studying this subject. Not only this course, any course, before studying the course you have to know what are the objectives inside of that, and according to the objectives whether I have to study or not, you can decide, and then you can go to the course outcomes. What is the course objective and what is the course outcome? The course objective is nothing but the objective of the course, what we have to be studied, you have to study, not studied, what I have to study in that course, that will be described about the course objective. And after studying that course, what we will get after successfully completion of the course, what we will get, that is nothing but the course outcome. So in the name only you can say that course objective, what is the objective, why have to study that course, and the course outcome is nothing but the from that studying, by studying that course, how what you are getting from that course. So next we will discuss the course modules or course syllabus and textbooks. What are the different textbooks have, and what are the main textbooks, and what are the reference textbooks have, and what are the different electronic resources like our ICT videos and other things. These are the different modules we will discuss. One means what each module, what are the syllabus we have, and those all will be discussed in the modules. And what is the probability and different calculations of the probability, and some problems of the probability also will be discussed in the same here. And the types of probability, how the probability should be defined, what is the difference between conventional probability and what is the difference between theoretical, the different empirical probability, subjective probability will be discussed in that time. And the applications in the engineering, what is the applications in the engineering also will be discussed. Coming to the course objectives, previously have said that course objective is nothing but the objectives of the course which you have, why you have to study this course, means the fundamental concepts of the probability and random variable modules used in engineering. We will know, by studying this course, we will know what are the fundamental concepts of the probability and random variables, and how it will be applied in the engineering problems, and the operations and transformation and properties of the single random variable, as well as the variance and transformation of the random variables also. And in the third unit, joint distribution, independency, and operations on multiple random variables. And last one, the classification and the ergodic process spectral properties of the random processor will be also be discussed in the fourth and fifth unit. And coming to after the successful completion, we will get you can apply the probability theorems and standard distributions to solve the problems, and also you can compute expected values, variances of the transformations of the random variables, and also you can analyze the joint marginal conditional distributions of your multi-random variables, and also you can evaluate the temporal characteristics of the correlation function of a random process, apply power, spectral density, and noise components in the system analysis. I think as of you know that in +2 level, what is the probability and what is how to calculate the probability by considering the coin and throwing a die and deck of cards, and also different kind of problems already you know in the +2 level. But here you have to study again the probability introduction, and then you can go to the random variables and the operations on the random variables, and also multiple random variables and the operations on the multiple random variables also will be discussed here, random process. So coming to the modules, we have the probability module, probability and random variable module, and we have the probability definition through axioms, joint probability, conditional probability, and total probability, and different Bayes theorem, independent events, and the random variables definition, discrete and continuous mixed random variables, and distribution and density functions and properties, and binomial Poisson and Gaussian exponential Rayleigh, and different these are the different distribution and density functions. And we will apply the operations on that random variable to find the expected value and variance and skew and moment about the origin center movements, and different characteristics of the random variables also will be evaluated in the module 2, but it is on only the single random variable, not on the multiple random variables. And coming to the module 3, in the multiple random variables will be discussed here. Same here, whatever the things here discussed in the one random variable, we will consider random variable x or random variable y or y, anything in the module 1. Coming to the module 2. Coming to the module 3, here we will discuss about the two random variables at a time. By considering the two random variables in the sample space, we'll discuss the same operations like at the here. Because of two random variables, we'll call as all joint distribution, marginal distribution, conditional distribution of your two random variables, like that we will call. The same scenario will be replicated in the module 3. And also we'll apply the covariance. Here we will apply the for the joint distribution. Also we will apply the operations of the random variables. And what is the random process, means what is the stochastic process, and how the temporal characteristics, how the spectral characteristics. Before going to that inbuilt of that, what is the random process and what is stochastic process? Already you know that statistic process, stochastics and statistics. So before going in build of the subject, I want to discuss about what is the main difference between stochastic process and statistic process. The statistics means we have to apply the whatever the data we have randomly, we have to apply the formula on it, and you can get the average or anything you will get by applying that formula. That is nothing but a statistical process. Without applying anything, whatever the data we have, that the random processes we have, that will be nothing but a stochastic process. If you want to if I want to elaborate more about this, we will consider one example. If you consider a mall, any suppose in our like Manjira Mall, Lulu Mall, like that, if you take any malls, while entering into the mall, we have a counter at entrance of the each mall. This counter is nothing but it counts number of customers inside the mall inside the mall, whatever that, it will give count. So it is a random process because in some situations in 1 minute 10 people will go. In another minute, after 1 minute, in another minute they will go only 5 people. So it is a random process. We can't know whether how many people will go in 1 minute. But if you want to know average of the number of people going inside the mall, will be known by applying statistics. Means like if you want average of a 1 minute, then we will get how number of people enter into the mall by total number of minutes or hours opened the mall. Means how many minutes the mall is opened divided by the total number, you will give the average of the 1 minute. It may vary. Here 10 people and 5 people is the random process, but here after applying the statistics it will be vary. That is nothing but a main difference between the stochastic process and statistic process. I hope you will get. And that random process, you have temporal characteristics with respect to the time and spectral characteristics, and the random process temporal characteristics and the spectral characteristics with respect to the frequency. And we have different textbooks. One thing I have to mention here, didn't mention the textbook name called by Mallikarjun Reddy. It is also a very good textbook for this Mallikarjun Reddy. And it's published by University Press. And you have different editions. You can consider any edition. Basically, 4th edition is available now in our library. So 4th edition. So instead of that, Pebbles also a good book. Murray is also textbook. P. Ramesh Babu and Athionisis and K. N. Hari Bhatt is also a good textbook for the studying this probability theory and stochastic process. And these are the different electronic resources available in our college to study this, not in our college, in our websites, like different Swayam MOOCs, NPTLs, all NPTL videos are given here. So you can, by seeing that NPTL videos also, you can get the knowledge on the PTSP. And coming to the probability, what is the probability? Probability is basically origin from a game called gambling. In the previous years, gambling is a game. In past decades, gambling is a game which is ethical, not non-ethical. So in not in our country, in foreign countries, gambling is a game. So so many members are only one. As you know that if any game, only one will win and other will lose. So that losers will think about how to calculate the winning chances. So in that from that game, the probability will came into the existence. So after that, different scientists like different mathematicians are came into the this probability calculations and gave the different scenarios to calculate the probability. What is coming to the our probability? Probability is a mathematical study of chance. So it's a chance how how we will win or how the favorable outcomes will there. Mathematical study of chance, it measures how likely an event it to occur, how likely an event to be occur, and the ranging from 0 to 1. And one more thing is the probability is the thing which will be lies in 0 to 1. We'll discuss later about that. And the basics of probability, to understand the probability, it helps to break down few key concepts I have. Experiment. I'm taking an experiment, an activity with uncertain result. Example, rolling a die. You have die. You know that the die has 6 faces, and one opposite 6 and two opposite 4, 5 opposite 3. And if you take that die, if you want to throw that die, it is a random process. You don't know what will be occurred on the die. So that is an activity with uncertain result. We don't know the result. So that's why it is called uncertain result. If I rolled the die, a single possible result of an experiment, that is called example rolling a 4. How many outcomes are there in a die? Outcomes. One comma, 2 comma, 3 comma, 4 comma, 5 comma, 6. These are the 6 outcomes. From this, he's asking what is the probability of getting 4. Here, the thing here is the specific outcome or combination of outcomes you are looking for. Example, rolling an even number. So that is 2, 4, 6, not 1, 3. These are not. So for these are type of chances, how to calculate the probability will also be discussed here. How we'll calculate? Theoretical probability is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. P of the event is equal to the number of favorable outcomes divided by the number of possible outcomes. Suppose if you take the previous slide, here I am taking an activity of rolling a die and I want to get a rolling a 4. How the probability will be? Probability is nothing but what I have told, that probability is number of favorable outcomes. How many favorable outcomes for getting a 4? For getting a 4, only the 4, 1 is the probability. So 1 by means only one time is the probability, because one time only it is thrown the die. So out of 6 outcomes, total outcomes are 6. From the formula, number of favorable outcomes divided by the total number of outcomes is nothing but 1 by 6. Similarly, if you give the event a specific outcome, combination of outcomes you are looking for, that is even numbers. How many even numbers are available here? 2, 4, 6. That is number of favorable outcomes are 3 by 6. Nothing but 1 by 2. Okay. Like that we will calculate the probability. Already here discussed about that only. Whatever the thing, when rolling a 6 die, but the probability of rolling an even numbers, that is 3 by 6, and that is nothing but 1 by 2 is nothing but 50% of chance, because out of 6, 3 numbers are even and 3 numbers are odd, so 50% only the chance. So types of the probability, whatever the different types of the probabilities we have, depending on the scenario, the probability can be approached in different ways. That is theoretical probability, empirical probability, and subjective probability. What is this? What is the theoretical probability, empirical probability, and subjective probability? Means the theoretical probability based on logic and reasoning. Example: calculating a coin flip without actually flipping it. Calculating a coin flip without actually flipping it. It is nothing based on logic and reasoning. We'll think and logic. You have to apply the logic and you have to find that probability is nothing but a theoretical probability. And empirical probability based on observations. Based on observation, it not be done, but by seeing only you have to tell about that. That will be nothing but a empirical probability. And then subjective probability is nothing but a based on individual person judgment, not experience or institution. I think there is an 80% chance in the rain because the sky is getting dark. This is a assumption, like as a individual perception judgment. So that type of probability, 80% of chance, it is also a probability, but it is an individual probability. I will tell 70% chance as a 50% chance. That type of probabilities as a subjective probabilities, we will call it as a subjective probability. And what are the key applications in our ECE? We will use in signal processing and noise for calculating the noise, and in the digital communication and information theory, and the semiconductor manufacturing. Meaning the semiconductor manufacturing, if you want to know the defectives in the how many defectives are coming for a manufacturing while manufacturing any chip, will be known by the semiconductor, will be known by the probability. So axioms of the probability. Before going to the axioms of probability, I think you have to know what is the exact meanings of axioms. What is axiom? Axiom is nothing but it is the thing which has to be true. That's it. We don't have any proof for that. We don't have any proof, but it has to be followed by the universe, not us. It has to be followed by the universe. What is that axioms? Why you are studying? Why you are seeing for axioms is nothing but a thing which has to be existed. No need of any proof. We have to follow that. That's it. That is nothing but an axiom. For any event of A, what are the axioms of probability? What we have to standardly follow for an event. First one is P of A greater than or equals to 0. That is what probability is a non-negative number. Means it should be 0, from starting from 0 to a positive number only. That is the first axiom. No negative numbers. No negative numbers. And coming to the P of whole sample space is equals to 1. Means probability of the all the events occurred in any experiment, probability is the whole set is unity. Means it doesn't exceed the probability to 1. First axiom is it should be positive, that is 0 to, and second axiom is and highest value of the probability is 1. Means the probability will lie between 0 to 1 only, not more than 1 and not less than 0. And if A intersection B is equals to pi, what is the intersection? The common point, the common, if you have two events A and B, what are the common event, what are the common possible outcomes from A and B will be the intersection. If A intersection B equals to pi, means no measures of the A and B will be matched, then P of A union B is equals to the, means P of probability of A union B is nothing but a probability of A and probability of B. The summation of both will be give the probability of occurring the two events, because intersection, no measures in the intersection. So coming to the some problems on probability, simple problems I have taken here. We will see what is that. 3 unbiased coins are tossed. What is the probability that most one head occurred? Here what is saying? 3 unbiased coins are tossed, and what is the probability that at most one head occurred? So first we have to check what is the probability definition. Number of favorable outcomes divided by total number of favorable outcomes. Sorry, total number of outcomes, not favorable outcomes, outcomes of an event. Here favorable outcomes. So first If you want to know the favorable outcomes, we have to know what are the total outcomes. From the total outcomes, we will check what he want and what is the probability of that event. Here the event is the probability that most one had occurred. So before going the total number of outcomes, you have to calculate for this event. What is this event? 3 unbiased coins. So 3 unbiased coins, how many outputs will be there? The outcomes are 2 power. 2 outcomes will be there for any coin, head and tail. This is tossed 3 times, so 2 cube. That is nothing but 8 outcomes will be there. So what is that 8 outcomes? Head, 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 tail, head, and tail, head. And this is till tail to tail. 1, 2, 3, 4, 5, 6, 7, and 8. So total 8 possibilities. If I toss 3 coins, there is a probability that all should be heads. That is the first outcome. And one coin is tail and 2 other coins are head. Means first coin is head and second coin is head and third coin is tail. Similarly, if I toss 3 coins, first coin is accorded as head and second coin has a tail and third coin is the head. So like this we will write the 8 outcomes for the favorable. So he's asking one head. Favorable outcomes 1, 2, 3, 4. At most, at least means 1 or more. At most means 1 or less than 1. So how many heads at 1? These are more than 1. These are also more than 1. These are also more than 1. And this is head more than 1. And this is only 1. So it will be counted as favorable outcome. And here also 1 for favorable outcome. And this is also 1. And here also less than 0. So 4 outcomes are there. At most means. Total number of outcomes are 8. So number of favorable outcomes are 4. 4 by 8. The required probability is nothing but number of favorable outcomes by total number of outcomes. Nothing but 4 by 8. Nothing but 1 by 2. That is nothing but a 50%. 0.5 or 50% you can take. There is a chance of getting, when you toss a 3 unbiased coins at a time, what is the probability of most one head is, at most one head is nothing but a 50% of chance will be there. Means 50% has to come. That's it. There is no other alternative. Before we are applying a experiment, we knowing that there is a chance of getting 50% of chance for getting an event. So if you go into the second question, find the probability of getting a red card when a card is drawn from a well shuffled pack of cards. Before going to the cards, already we know, I think already 52 cards divided into 13, 13, 13. And these are the ace, queen and king, and then 1 to 10, 2 to 10, sorry. Like that we will say, similarly we have that. Like that ace and will be queen and king and one jockey will be there, and this is the 52 deck of cards. He's asking getting a red card. So total number of outcomes in how many? 52, because those are 52 deck of cards. Number of red cards will be 26. 26 red cards and 26 black cards. So 26. And the required probability is 26 by 52. The number of favorable outcomes divided by the total number of outcomes. Nothing but here 50% of chance. Coming to the another example, a bag contains 6 white balls, 4 black balls, and 2 balls are random from the bag. Find the probability that both the balls are the same color. It doesn't mention either white or either black, but he's asking what is the probability of getting both colors should be same when I'm picking a 2 balls are done at random, means 1 after 1. So outcome will be favorable if the 2 balls are drawn of the same color. Number of favorable outcomes are 6C2, means 2 balls are considering from the white, that is 6C2 combinations and 4C2 combination, and the total is 21 of outcomes. Total number of outcomes are 10C2, because 6 and plus 4 10. So 10 C2 is nothing but 45. Therefore, the required probability is favorable outcomes divided by the total outcomes, that is nothing but 7 by 15. So this is the another type of problems. If you coming to this, a tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. So if you want to replace a tire, and then the table shows the result of 1,000 cases. He has taken 1,000 cases Then if a tire bought from this company, what is the probability that it has to be substituted before 4,000 kilometers is covered, and it will last more than 9,000 kilometers, and is to be replaced by 4,000 kilometers and 14,000 kilometers covered by it. This is the different probabilities asking by using this table. If you see here, distance in kilometers is given, frequency less than 4,000 kilometers, 20 tires are changed. 4,000 to 9,000, 210, 9,000 to 14,000, 325 probability means out of 1,000 cases, 20 cases are replaced out of 20,000, 4,000 to 9,000, 210 cases, 9,000 to 14,000, 325 cases, more than 14,000, 445 cases. There's a total 1,000 cases are considered. So he's asking it has to be situated before 4,000 kilometer is covered. What is the probability here? The less than 4,000 means here also it's substitute before 4,000 kilometer. Less than 4,000 kilometer, how many members are changed? 20 cases are occurred. 20 cases, total 1,000. So the total number of trials are 1,000. The frequency of tire to be replaced before covering 400 kilometers are 20. So 20 by 1,000 is nothing but probability of that event. So the frequency the tire, next problem, it will last more than 9,000 kilometers. More than 9,000 kilometers means this one. This is 4,000 to 9,000 only. How many? So the frequency tire will last more than 9,000 kilometers means 325. More than 9,000 and also more than 14,000. 325 plus 445 is nothing but 770. So P of the event 2 is nothing but 770 divided by 1,000. Because these two events will comes under the greater than 9,000. That's why you have to calculate 325 plus 4. The frequency of the tire replacement between 4,000 kilometer to how many? 14,000 means these three will becomes 210, 325 and will 535. 535 divided by the 1,000. Kilometer to 40,000 means it will not want because before that only he's asking. So it 210 plus 325 nothing but 535. And next problem, one card is drawn from a deck of 52 cards well shuffled. Calculate the probability that a card will be an ace and not be an ace. Simple. In out of 52 cards, how many aces are there? 4 aces. So these are the favorable outcomes. Favorable outcomes are 4 aces. And total events are, total outcomes 52. So probability is what? Simply 4 by 52. That's why there are 4 aces as a deck. Let A be the event of a quadrant has. The number of favorable outcomes are 4. The number of possible outcomes are 52. Therefore, P of the event is 4 by 52 is nothing but 4 13s are 1 by 13. Okay, understood. And he's asking about that the probability of that the card will not be an ace. Will not be an ace. Means as you know that the probability of the event occurred plus probability of the event non-occurred is should be equals to 1. Here is asking probability of the event non-occurred. So what is the probability of the event non-occurred? P of A bar is equal to 1 minus P of A. That is nothing but probability of non-occurrence is equals to 1 minus what is the occurrence probability? 1 by 13, nothing but 12 by 13. So this is the reason the number of favorable outcomes 52 minus 4. Like this also we can do. Because 4 events are occurring, so we have to minus the total number of favorable outcomes, that is 48 by 52 is nothing but 12 by 13. Otherwise you can apply this formula also. Next, coming to the another problem, two players Sangeet and Rashmi play a tennis match. The probability of Sangeet winning the match is 0.62. What is the probability that Rashmi will win the match? Simple. Already he is given what is the total probability. Total probability should be in between the 0 to 1. So he is given that for P Sangeet, if I taken the event of getting winning by the Sangeet P of S, and another one is Rashmi P of R Rashmi. So probability of getting win by the 0.62. Total probability is 1. 1 minus 0.62 will be give the Rashmi's winning. So that is the 1 minus 0.62 is nothing but 0.38 is the Rashmi will be the probability for winning the game. So consider experiment rolling a die. Let A be the event getting a prime number. B is the event getting an odd number. Write the sets representing the event. Simple. I have rolled a die considering an experiment. Already we know the 1, 2, 3, 4, 5, 6, and is asking the what is the sets you have in there. For even, let A be the event of getting a prime number, B be the event of getting an odd number. First you have to check an event A, that is the prime number events, and event B, that is an odd number. So what are the odd numbers you have? 1, 3, 5. And what are the events of the prime number? 1, 3, 5. 2 was, sorry, prime number is comes to 1, 2, 3, 5. So coming to here, A or B. A or B, nothing but A plus B. A union B. So what are the events we have in the here? 1, 2, 3, 5, 1, 3, 5. So the common events are 1, 2, 3, 5. So that's why A union B is 1, 2, 3, 5. And A intersection B. Here 3, 5 is the common events, and A but not B, A minus B, nothing but, and not A means A bar. Means whatever the other events you have, that is nothing but here other events. This is the problems and probability. Thank you.